Let's examine why the equation v equals v plus v naught over 2 is not valid when acceleration is equal to a plus bt, where a and b are constants. Let's start by understanding what this means graphically. When acceleration is equal to a plus bt, it forms a straight line over time. This is different from constant acceleration, where the line would be horizontal. In our case, the acceleration is continuously changing with time. To find the velocity, we need to integrate the acceleration with respect to time. The integral of a plus bt dt gives us at plus bt squared over 2 plus a constant of integration, c. Using the initial condition that velocity equals v naught at time equals 0, we can determine that c equals v naught. Let's see what this means for the velocity graph. The velocity is no longer a linear function of time, but rather a quadratic function. This means that the average velocity cannot be found by simply averaging the initial and final velocities, as that method only works for linear velocity functions. The equation v equals v plus v naught over 2 is only valid for constant acceleration, where the velocity time graph is a straight line. In that case, the average of the initial and final velocities would give us the velocity at the midpoint. But with our quadratic velocity function, this is clearly not the case. The actual average velocity would need to be found by integrating the velocity function and dividing by the time interval. Therefore, we have proven that the equation v equals v plus v naught over 2 is not valid when acceleration varies linearly with time. This formula only works for constant acceleration scenarios.